All right, today it's all about inequality word problems. So our learning targets, what we're shooting for today is to be able to write a inequality from a sentence. And if that sounds familiar, yes, we have already done this with equations. We have looked at sentences and tried to write equations. Now it's our time to write inequalities, and it's going to be very similar. You're also going to be able to answer real life questions. So we do all this work with inequalities, and you're like, well, what's the big deal? When am I ever going to use this in my real life? Today we will show you places where it could be used. So some key ideas to remember: make sure you use let statements to define what you don't know. I know they seem like a pain in the butt, but they are super important in order for us to kind of get going. Underline, annotate important parts of the question, and make sure the answer makes sense. If you get an answer that doesn't make any sense to a real life question, you probably have done something incorrectly. Okay? So, first one is about a club. So we're going to, okay, stop that. Solve these real life questions involving inequalities, and this time a club is selling a box of candy at a profit of $1.50 on each box. How many boxes must be sold to make a total profit of at least $650? So there's our annotating. Now it's important for us to go back and, there's our underlining. Now it's important for us to go back and do our annotating. So a profit of $1.50 on each box is our rate. All right, so we talked about our ROC and our IV, our initial value. So this is our ROC, our rate of change. And then to make a total profit of at least $650, it would be important to give the sign for at least. At least means greater than or equal to. So if it's more than, that's totally fine. It just can't be smaller than $650. We're trying to make that much money. And then what we don't know is the variable. So what it is that we're trying to solve. So what would that be? Well, the question right here says how many boxes must be sold. So let's let B equal the number of boxes. It'd be helpful if I could spell it correctly. Boxes sold. So we've annotated, we've given ourselves a variable. Let's see if we can make a inequality. And a lot of this is pretty simple. Now that we know that the B stands for box, we have $1.50 per box. And that's a rate. And a rate will increase or decrease depending on how many boxes we have. So one box, $1.50, two box, $3, three boxes, $4.50. We're just multiplying those together as a rate, okay? And then at least $650 is what we want to make. So greater than or equal to $650. And there you have it. You have just written a inequality from a sentence. Pretty straightforward, exactly what we talked about a few lessons ago. Now we do want to solve this for how many boxes. So let's divide by 150. So we're going to solve this like we do any other inequality. That's going to leave us with just B, because this is going to make a 1. Now we divide it by a positive, so careful. You do not switch the sign. Some people had some trouble with when to switch the sign, when not to. So in this case, dividing by a positive does not have an effect. And this ends up being 433.3. Now, we want to know how many boxes we have to sell, and we ended up with a decimal. We want at least, meaning bigger, meaning more, so we need to round up. So let's write a quick little sentence that says, the club must sell 434 boxes to make a profit. Okay, because if they didn't sell, if they only did 433, they'd come up a little bit short of their goal. All right, so hopefully that's a nice little transition getting us into the idea of what's going to be happening today. Let me know if you have any questions. Next one. We've got just some phrases, okay? So some basic terminology here that we want to use. So let's make sure we understand, what we talked about earlier in the year about less than and half and our inequality words like at least or twice, and some, a number, 8, and at most. All right. But what we really need is a variable. So let's let n equal the number. And why don't we let that be the number for both of these? So I'm going to slide this into the middle so we can just use the same variable for both. That'll be much quicker. All right, so we're just going to simply go through here and maybe do a little annotating. 5 is 5, less than is subtraction. 1/2 is n. At least, we just saw that, meaning greater than or equal to 7. So can we use the same order that we read this in? No, remember that less than does change the order. And instead of writing this as 1/2, I'm going to write n divided by 2. And then less 5. So there's your half of n less 5, at least, meaning greater than or equal to, and then 7. So there you have it. Just a real quick transition, a real quick simple one there. The other one, how about twice the sum? Let's do some annotating for this. We got twice for 2 times. Sum means to add. The number we're using is n and 8. At most, meaning no bigger than, so that's less than or equal to. That thing just is getting in my way this morning. 4. Now, we got a problem with this. We've got a number and a variable, but we're being asked to add these. So remember that the word and can sometimes mean different things. In this case, it means to add. So I want to do twice the sum of n plus 8. And I got to pause for a moment. Is that really twice the sum? Are we really doing 2 times that addition problem? Not until we put parentheses in. So again, everything that we learned in this class comes back again. So hopefully we have a strong foundation for what we've already done. And then it's going to be less than or equal to the 4. So if that looked easy, think about what we did. We did a let statement. We did underlining. We did annotating. All of those things seem simple. They seem kind of unnecessary, but they really make it a lot easier for us. We're not going to take the time to go back and through and solve these. I know that you're good with this, so we're going to move right on to the next slide, unless there are any questions. Let's say on average a class of mine would score like 200 points a day. It went like 5, 10, 15, 20. We had some special shots, so 200 points a day was pretty manageable. A class would accumulate points over the course of the year, and they'd earn different parties. And so let's say your class has 1,700 points to start. How many classes will it take to exceed 4,000 points, set up an inequality, use let statements, and solve the inequality? All right, well, I'm going to go right to the let statement. So let's let. The let statement is always based on what we don't know. How many classes? Okay, so let's let C equal the number of classes. And now let's go back and do some annotating. We've talked about slope and y-intercept and rate and initial values so much. I hope by now we can really identify these quite easily. 200 points per day. Rate of change, right? That is your rate. 1,700 points already. That is your IV, your initial value. And we want to exceed. So that is simply greater than. It's got to be bigger than the 4,000 points. So let's put it all together. 200 points per class. If it's one class, it's 200. If it's 2 classes, it's 400. If it's 3, it's 600. It is just that easy. I got to get you thinking that this is easy, not kind of craziness. And then we had 1,700 points at the beginning, and we want to exceed, which means greater than, 4,000 points. People that exceed the speed limit end up getting a speeding ticket. All right, anybody's parents ever gotten a speeding ticket before with them in the car? It's kind of a weird experience, right? All right, let's go through and solve this for the number of classes. So we're going to subtract 1,700 on both sides. All right, that will zero out. 200C greater than, how about 2,300? Divide each side by 200. And the number of classes would be greater than. Very important that you keep with that inequality sign. It's very common for students to kind of go back to the equal sign because we work so much with it, but 11.5 classes. Well, that's fine. So sentences are always better than sentence fragments. It will take 12 classes to exceed 4,000 points. All right, so there you have it. How you would score that many points in a normal year when I'm playing some basketball in my classes. I've only got one more example, folks, and this brings up some bad memories for some folks. Remember those consecutive integer questions that we're doing from lesson number 8? Yeah, they're back. All right, so let's get through this. It won't be that bad. I think when you step away from something and come back to it, you'll have a fresh set of eyes and it'll make more sense to you. So we want to find the sum of two consecutive even integers that's at least 18. Identify the first possible even integer, and obviously I'm suggesting that you set up let statements. Very important that we do this when we're talking about these numbers. So let n equal the first even consecutive integer, CI, consecutive integer, okay? And so remember that even numbers go by 2's. So the next even number would be 2 more than the first. So there we go. There is our second even. So again, this is coming from lesson 8. If you need a little help, a little refresher on this, let me know. We can do this during the office hours tomorrow. But we are told that the sum of these two consecutive integers, so sum means just simply to add. So I'm adding the first number n with the second number, which is considered n plus 2, and then we have at least. So this would be greater than or equal to, and our total is 18. Go ahead, add numbers in front of the variable so that you can see this is 1n plus 1n for 2n plus 2 greater than or equal to 18. We're going to subtract 2 on both sides. 2n greater than or equal to 16. And then I want to divide by 2 on both sides. So if I do that, I'll end up with n being greater than or equal to 8. And the number that I got, is it an even number? Yes. It's not a decimal nor a fraction. Remember that these are integers, so they have to be a counting number. And the first even integer could be 8. You know, with the next one being 10. 8 and 10 would be possibly our first two numbers.